Now we're ready to try subtraction in other bases on the base in abacus. So I have a problem here. I'm set up for base 3. I have 3 singles down below, nothing up top. And the problem I want to do is 22012 minus 2112. First I have to set up 22012. So here's 22012. And now I want to subtract 2112. So I just take away. I'll start with the ones place. I need to take away this 2 from that 2, so I just take it away. I need to take away from the 3's place. I need to take away 1. So there's that. From the 3 squared place, I need to take away 1, but there's 0. So I'm going to borrow. I borrow this one, which is worth 3 of the place value before it. So here's my borrow and carry. And now I want to take away 1 from that. And now I want to take away 2 from the 3 cubed place. There's 2 in the 3 cubed place. It's the 4th place value over, so 1, 2, 3, 4. I need to take away 2 from that 1, so I borrow. Now here's the problem. Either I borrow and I'm bringing 3 over and I don't have the beads for that, so I can subtract off 1 of the 2, and then I can borrow from this one and replace it with 3, and then take away the second one. That's one way to do it. So I'll leave it at that. And you can think about the net add subtract that we did with base 10 earlier on the abacus and Soroban. So we'll stop there. So we stop there with the subtraction, and we just need to look at the answer, and we see it's 12200, which when we write it down, it's 12200. All we did was read it off in base 3, 12200. Now I have my abacus set up for base 8, and I apologize for the twisting of the pennies up here. I have a very limited visual space for the camera, and so this is the only way I can squeeze it in for base 8. So what I'm going to do is when a penny takes on value, it's going to actually be on the center line instead of just near it, and that way we're clear on it. So I have 4 beads that are below, worth 1 each, half of 8. I have 2 beads above that are worth 4 each for a total of 8, just like we saw in base 6. The problem that I want to do is 74123 minus 6754. So the first thing I need to do is set up my 74123. So I say this is 4, 5, 6, 7, and then let's make it clearer there. So there's 4, 5, 6, 7, and then there's 4, and there's 1, and there's 2, and there's 3. So 7, 4, 1, 2, 3. And I want to subtract off 6, 7, 5, 4, and I'm going to work from right to left. So I need to take away 4 from the 3. I'm going to borrow, so I borrow from 1 decimal place or place value, sorry, 1 place value to the left. That gives me 2 of those. I need to take away 4, so I take away one of them. That leaves the other. That leaves me with 4, 5, 6, 7 here on the right. Now I have 1 here on the 8's place. I need to take away 5, so I'm going to borrow. I borrow the 1 here and turn it into 2 of those. And now I need to take away 5, so that's 4 and 5, leaving the 4 there. Now I need to be at the 8 squared place and take away 7. I have 0. I have 4 here, so I can turn in the 4 for those 4, and then I borrow 1 and turn it into the 2 4s, so that's 8. And now I want to take away 7, so I take away the 8, that's a negative 8, and I add in 1 to make it a negative 7, a net negative 7. Finally, I want to take away 6 in the 4th place value. 1, 2, 3, 4. I have 3. So I borrow 1 from the next place value over, and I bring down those. That's 8. And I need to take away 6, so I take away 4, 5, 6. And my final result is 4, 5, 6, 5, 1, 4, 7. So let me write it in. 6, 5, 1, 4, 7. And I see that answer. Remember, the ones touching here are worth 4. So 4, 5, 6, 4, 5, 1, 4, 4, 5, 6, 7. A lot of borrow and carry there. We don't even have to really know base 8 other than what the values of the pennies are. 4 above each and 1 below each.